Hello everyone, welcome to Reactify Labs. Today we will do the low level designing of the game of chess. Hmm. So, we all know what chess is. I agree we might not be an expert in playing, but we know the basic rules, right? That there will be a board, 8 by 8 cells, some pieces, and they will just fight amongst each other, right? So, what should we do when we are presented with the question of, let's say, in the interview, we are asked to design chess? What should we do? Should we directly start making classes uh, and the diagram, right? No. We should still talk to the interviewer. We should clarify our requirements. It is possible that the interviewer does not want you to implement all the functionalities that is there in chess, or it is possible that the interviewer expects you to implement some additional functionalities in the chess. Let's say the interviewer wants you to make a three-player chess game. It's possible, right? I'm not saying he will do it or she will do it, but it's possible. It's up to the interviewer how that person wants to modify the question, okay, or frame the question. So you should always clarify your requirements. So we will start with our requirements gathering stage. So requirements. So at this stage, what you can do is you can uh, talk to the interviewer that if that person wants to give you the requirements, or you will talk through the requirements and that interviewer can tell you, okay, yes, let's do this or let's not do this. Okay. So it's your job to clarify the requirements uh, at each step. Okay. So since here it's a monologue from my side, I will just list down the requirements, but you should always talk to the interviewer on the requirements stage. Okay. So it's possible that if you didn't talk to the interviewer and you just drew the classes, by the end of the interview, interviewer might ask you to uh, like talk about a certain functionality, but you would say you didn't talk about it. Then the interviewer will blame you that why didn't you ask it? Why didn't you clarify from me? As an engineer, your job, your first job is to clarify all the requirements. There should be no ambiguity. Okay, so that's why the requirements gathering phase is very important. So the first step or the first requirement would be, let's say, mm, all the rules all the rules of international game of chess will be followed. International chess game will be followed. So this already takes care of a lot of things for us, right? Like the move of king, queen, pawn, bishop, a lot of things. Next, it should be a two-player game. Hmm? Okay. Next, um, the board should be 8 by 8. The board should be 8 by 8, right? The colors, you can assign any colors, but just for the sake of um, this one I am taking black and white. You can also start with, let's say, red and green or blue and yellow. It's up to you. Okay. Colors can be either black or white. Then each player may get assigned a color or the side randomly. Hmm? Okay. Next, the moves will be alternate. The moves will be alternate with white playing first, because that's the rule of chess, international rule, with white playing first. Okay. Next, what we might talk about the pieces, like there will be 8 pawns, one king, one queen, two knights, two rooks, and two bishops. Hmm? So each player will have these pieces, right? Mm, there should be something like the player cannot cancel the move. The player once played cannot go back, right? So yeah, this is almost everything. Maybe you can add, like, the game will end on one player losing or a stalemate. Hmm? Right? So how this losing and stalemate happens, this will be a separate concern. This logic, if the interviewer asks you to write this logic, only then you will have to write it. Otherwise, you have to show your classes how they will interact. Okay. So this is our basic game of chess. You would agree. So if it's like the uh, if you do not talk to the interviewer, okay, then you might start with this, and interviewer might ask you something later, like the question may be, let's say we want to know, in your 10th step, when you played the 10th time, what did you do, right? The interviewer can ask you. So at that time you won't be in a position to answer that question, because you never talked about if you are going to that keep a history keep a history of the moves, right? So maybe while you were gathering requirements, you might ask this thing also. Okay, there will be a history of all the moves. There will be a history of all the moves. Hmm? Maybe let's say the interviewer also wanted to know that, okay, in a particular move, let's say in the 10th move, you moved, let's say, coin x or piece x. So did you do it right, did you do it wrong? Because there are other online platforms which can tell you that, okay, see, if you moved this one, this was a bad move, this was a terrible move, or this was an excellent move. You get a lot of feedback, right? So maybe you can implement that also. Maybe you can implement a leaderboard also. Maybe you can implement something like mm, play until lose, right? In which you just keep playing with somebody until you lose, and that's how your points or streak continues. So there are a lot of things which can be implemented even in a simple design system like game of chess. But it's up to you and the interviewer. You have to do a conversation to figure out all these things, and only then you have to start drawing classes. So for the sake of this video, I am going to go with only these requirements, right? So once we have our requirements, let's talk about the classes or the uh, use cases which we will be going to see here. Okay. So if we talk about what will we do, so maybe let's say what we can do is we can first play. Okay. Play is basically move a piece. Okay. Also, if you see, before moving a piece, you have to check that if your particular movement is valid or not. What if moving a piece brings a check to your king? What if moving you are like the place where you are trying to move is blocked by another piece there? Or it's let's say if it is a move like for a piece, if it can move only this and this direction, and you are trying to move it here, right? So that's not possible, right? So there can be something like validate function also. So you have to validate a move. Hmm? Right. Maybe what you can do is you can update your account, maybe not account, like in chess you get a ranking. With every game you get some ranking. If you win, you get more points. If you lose some points. So some things like this happen. So maybe let's say update points. Hmm? Maybe before playing, actually in the chess.com you have to register your account. So maybe register. Okay, register your account. Maybe while playing you can, if you see that there is no point playing now because you have already lost or you will eventually lose, then you can forfeit the game also. Forfeit the game. Hmm? So these are some things that you can do. Actually, yes, there's a history also. So you can, at every step, at every move, gather the history. Hmm? Gather as in, I don't think gather is the right word here. It should be more like um, maintain history. Hmm? So that you can always go back to that state and check what you did there. Hmm? So these all are the use cases. Now let's see what are some of the important classes for this game of chess. So what all classes will be there? You are a player, right? So there will be a player class. Two players, so there will be player class, and player class will have two objects just to signify two players, right? Next, there will be a chess board, right? There will be a cell in board. This is the board. So these are cells, right? So there will be cells. Board, cell. The cell will be a class, right? So there will be 64 instances of that cell. Hmm? Next, what? There will be pieces. So it will be a piece class. So the piece class can have multiple children, like the king will have another class, the queen will have another class. So there will be different classes for that, but the parent class will be piece. Hmm? Next, if you have to move one piece from this place to this place, what happens is its position changes, right? So this in itself has a lot of information, like what piece is here, who played a particular move, what was its x and y coordinates, so a lot of things. So move is going to be another class. Okay, next, what happens is, as soon as you start a game, you get a board, right? So before you started the game there was no board. So the board and everything inside it, the history, player, everything is in the game. So you have to make a game class also, right? So there will be a game class which will have these instances of boards and cells and a lot of things. Okay, now what? Anything we left? There will be player, board, cell, piece, move, game. I think we have almost everything. Yeah, we have almost everything. So we can start drawing our uh, class diagram. Okay, how different classes will interact with each other. So we'll start with some things which are very obvious. So what are obvious? If you see, the piece is obvious. The piece is obvious. Piece will have what? The piece will have like nothing specific, just like if it's alive or not. Is the piece alive? It may have a boolean value, yes or no. Okay, and the piece will have a few things, like let's say is alive, a method which will just return something from this alive, uh, whatever the value of this alive is, it will return that is a live method. Maybe something like color, get color, or this get color can return something like maybe yes, white or black. But since we know that we have only two values, white or black, then we can in this case do something like is white or is black. So this boolean will suffice for this, right? So this is a piece, this is the parent class. So we will have some children of this, right? So first one will be, let's say we'll start with queen. there will be a queen, there will be a king, there will be pawn, there will be rook, there will be bishop. 1 2 3 4 5. What else is left? I forgot. 1 2 3 4 5. Okay, we are good. Knight. There will be knight also. Yeah. So these all classes. I'm sorry. Yes. So we'll have these classes, and all of these classes are going to extend this piece. So there will be an extension of piece here. So this one, even this one, this one, this one, this one, and this one. So all these are going to be extending piece. So whatever is there in piece will be inherited, and they will all provide some additional functionalities. Maybe let's say something like, can they move, right? So let's say the move, or actually can move will be a better function. So can they move, right? When you hover over them, you can know that if there is space, then only they can move. So there will be a can move method in each of them. So all of them will have their own can move method, but if they are alive or not, and if their color is white or black, these things can be inherited from the piece class, right? So we are good with piece now. So let's cut it out. So we are done with piece. Or do it this. We are done with piece. Now what? Now what can we do? So this piece will be in a cell, right? So there will be a cell class, and for the cell class, it will have a row, it will have a column. And what is the position of this cell class or a particular cell? It can be given by two methods. Let's say get row, and we have another method called get call. So we'll have get row and get call. So the pieces will be inside the cell, right? So this piece will have an aggregation with the cell. Why? Because the cell will have the pieces, and this will have, I said aggregation, but this will be composition actually. This will be composition because the cell will have pieces, and the pieces cannot exist on their own. Although yes, you can say that the pieces exist on their own, but yes, out of the box they exist. But in the game of chess, when we talk about this, the pieces don't exist without the cell. So either the piece is there, let's say either the piece is here, or the piece does not exist. You cannot see it in the game, right? So that's why the piece is related to cell. The piece cannot exist without the cell. So that's why there will be a composition relationship. Okay. Now what? So this cell, the pieces will be in the cell, and the cell will be in the board, right? So let's mark the cell as done. Now the cell will be in the board. So we will have a board. We will have a board class. So the board class will have, again, this cell will be like this. So the cell does not exist independently on its own. The existence of cell depends on the existence of board. So this will also be a composition, right? So this will also be a composition. What all information will this board contain? So the board contain maybe a list of pieces, or it can have a list of cells actually, but what would be right? Because the board will have cells by default, right? So it will have a list of pieces. So what all pieces are there in the board? We know that the cells will always be in the board. There is no way the cells are going to leave the board, right? All the 64 cells will always be there on the board. But what piece is there on the board right now is the information. It's some information which we need from the board, right? So the board will have list of pieces. Okay. Now what? We have created board also. Now we will move to these player, move and game. Okay. So if you see board belongs to a game. But there is one important thing which you should know here. First thing is, when you start a game, what happens? You get a board, right? As soon as you start the game, you get a board with all the pieces at their right places, right? You get the board, the pieces are at their positions. But if you see one thing, throughout your game, throughout the duration of this particular game, there will only be one board. There will only be one instance of the board. One instance of board. So this is something which your interviewer can ask you. How will you make sure that there is only one instance of the board? For that, you will have to use singleton design pattern. If you don't know what singleton design pattern is, please go and watch this in the LLD design patterns playlist. I have uploaded a video on this singleton design pattern also. I have talked about it extensively, its use cases also, how you can ensure that only a single instance exists. Okay. So please go and watch that. It will be very helpful for you to understand. And not only chess, any game. Let's say tomorrow I have to make Ludo game, or let's say sequence game. So in all the cases, you will know that, okay, since for something there has to be only one instance, so there will always be one instance and there will always be a singleton pattern involved. So that's what you have to understand. And for that understanding, you need to first understand what singleton design pattern is. Only then you will know where to apply it, how to apply it. Okay. So let's talk about the game class now. So there will be a game class. Game class. What all information will this game class contain? So this game class will have the information like turn first. Whose turn is it? So the game will tell you, right, whose turn it is. Is it the turn of player 1 or player 2? It's the game. Next, game, the status of the game. Like, is it still going on, or somebody won, or was it a stalemate? Did somebody forfeit, or somebody defeated someone? All these things will be contained in the status of the game. Next, for maintaining the history, we may have a list of moves. Okay. So we will have a list of move. But what is move? We have to make that class also. So we will have a list of moves for the game. And game will also have some methods so that we can just query that to understand what's going on. So maybe in the game we have to, let's say that, okay, move this bishop from this position to this position. So move function. When we call the move function on the piece, it will move, right? Maybe get status of the game, right? So yeah, these are two things which can be in the game. And again, the board will be in the game. If the game does not exist, the board will not exist. So again, there will be a composition between board and game, right? So there will be a composition between board and game. Next, what we have, game also done, we have player and move. So since we are using move here in the game, let's make move first. So there will be a move. Let's write it here. So there will be a move. So move will have things like start cell. So from which cell the move started, end cell. To which cell did the move end, right? Player. which player made that move, right? Next, what is, like, did it kill something? Uh, did it kill, right? So, or actually, instead of writing it like a function, let's ask just killed. Hmm? So the killed will contain the information that okay, this piece got killed or null, right? So these information will be there in the move. Actually, then it should be small. So these things will be there in the move. And again, the move cannot be possible without the game, right? So this move will also be dependent on the game's existence. So again, there will be a composition relationship between the game and the move, right? So now that we have most of the things connected and most of the classes already addressed, so we have player to address now. So let's make a player class. Let's make it here. So there will be a player class. So the player will have details like, wait, the player will have details like the name of the player. The player has registered, so it must have some email address. What else? The player may have some things like the rating of the player, stats of the player, maybe win count, lose count, total games, how many total games has the player played, right? So these all things will be there. This information is contained within the player, right? So let's assume that we will have only this much information for now. What else? Are we missing something here? Yes. The player, if you see, the player will make the move, right? So the player will make the move, but move, if you see this, let's say player P1 played something from X to Y, cell X to cell Y, right? So what happened here? Does this need to be there inside the player that, okay, when we show that, okay, see, this is the player, the name of the player is this, the email address is this person once played a move from X to Y. Do we need this information? No, right? We do not need this. So the player and move are related, but not in this way. But how? It's like this. So a move like this, X to Y, happened. Who made that move? This player P1 made that move. In that particular game, in that game of chess, all the moves have a history, remember? So if something moved from this place to this place and we have to check the history, so we should know who made that particular move, right? So the history should contain all the information. It's just like logs. So we should know, so that even the player can go back and analyze what move was good or what move was bad. It's possible that the player loses the game. So in that case, the player will go back and check that, okay, see, I made this move. Maybe it was not the right move. The player will analyze and the player will learn from his mistakes, right? So that's why the move will always have player's information. So any move M will have the information like, okay, this player Px played that move or player P1 played that move, right? So this move will know about the player. The player will not know about the move. So there will be a unidirectional association between move and player. Okay. Next, what? The player, although exists. So let's say you signed up. You signed up for the game of chess, or you signed up for the chess platform, maybe chess.com. You signed up. So you still exist, right? You as a player one still exist. Even though you are not playing the game, you still exist. But if you are playing the game contains you. The game contains player P1, right? So it means there is a relationship between game and player, and this is an aggregation relationship. So the game will contain you, but you can exist without the game also. So that's why there will be an aggregation relationship between you two. Okay. So yeah, actually The player can also have, let's say, email ID, uh, password also can be given, because how else would you log in, right? So mm, let's add that. Hmm. So there will be password also, right? So did we miss something? Let's check. So what this player will do is, this player will play the game. The game will contain board, board will contain cell, cell will contain piece, and none of these can exist on their own. The game will also have moves. The move will have the information like which player is going to play that, or which player has played that move, right? So yeah, we have covered most of the things. I don't think anything else is left. So yeah, I think that's it. Like the last video, movie ticket booking, I made a mistake there, which I corrected in the description. There was an island, like there were four classes which were not connected to anything else in the diagram, so which was not right. Somebody pointed out, and I corrected that in the description, because YouTube doesn't allow you to edit the video after you have already uploaded it. So yeah, sorry for that. I'm just trying to make sure if I have left anything here. Hmm, game move. Hmm. I think I have covered everything. There is nothing left. So these are the children of this piece, the queen, king, pawn. So they are going to extend that piece, so they are also fine. Then the piece will be related to the cell. The cell will be related to board, board to game, and yeah, that's it. So yes, everything is there. So actually, if I have missed something, please let me know in comments. I'll try to not make that mistake again. So yeah, I hope this video gives you a good understanding of how to approach the question of drawing or designing the game of chess if asked in an interview. Always start with requirements, then use cases, then go back to listing all the classes, because once you list all the classes, you will know what all classes you have to draw, right? And while listing, you will also figure out if you have missed something. And once you have listed them, you can easily just draw them, and mm, just figure out all the relationships between them, if they will exist without each other or not, who is going to call whom, these things. So again, uh, you are not expected to write codes. You can be asked to write some code, like maybe somebody can ask you to, let's say, to tell what is the current status of the game, or let's say something like, if somebody has to move a piece x, okay, I don't know where, but if somebody has to only move piece x, can you first check if that piece can be moved or not? Implement this method, the interviewer can ask you. Or let's say that person says you have to move a bishop from x to y, can you check and tell is it a valid move or not? So these are some of the things which can be asked, but all actually this requirements gathering, use cases, classes, and diagram already takes a lot of time, that there is not enough time left to write code. Okay, and that's why you cannot be asked to write code. You can be asked to write code only if there is some time left and the interviewer wants to check also that if you know how to write code or not. So basic coding, if you know or not, only that can be checked here by checking these things. Just write a logic to check if a particular move is valid or not, if a move can be made or not. Or let's say, again the same thing that I mentioned above, singleton. So that question can also be asked, like how will you make sure that there will always be single instance of the board? So this question can be asked, because if you have mentioned that there will be only one instance of the board, interviewer might want to check if you really know what singleton is, or you are just talking about it, you just know it at a very superficial level. So that time you should not give interviewer the benefit of doubt that you do not know what design pattern is. So I would suggest study the design patterns also as much as you are studying the designs of the systems, because design patterns are the basis. They form the base of understanding the design, because you have to keep the basics in mind while designing the systems, right? So yeah, that's all I wanted to talk about in this video. Thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.